Hi there. Welcome to season 2 of AI Giants, a podcast where we dive very deep into the AI coding world with some of the most influential makers shaping the products we're using every day. I'm your host, Jaime George. Welcome to everyone watching on YouTube, X, and LinkedIn. Also, a very quick announcement as we start. AI Giants is now available as a podcast, so make sure to follow and get on Spotify via the link below. Should appear anytime soon. Let's go. And very excited about the first episode of 2026 with the unique Geoffrey Huntley. Jeff is best described as a goat farmer. He created Ralph a year ago and did a whole bunch of speaking before it was released. Jeff also did a lot of open source work, previously known as a maintainer of React extensions. Jeff, is excellent to have you today.
Thank you so much for having me here today.
Cool.
I'm looking at the run sheet that we're going to be going through, so strap yourself in, folks. It's going to be fun. It's going to be spicy. It's going to be lively. Let's go.
Okay, before we start, a reminder that you can post questions in the Q&A in our website, but also if you comment or make questions in YouTube, X, and LinkedIn, we have a number of folks that kind of just grabbing them and posting them here so we can try to answer them, and we will address them at the end. If we have the time, I don't promise to answer any single one of them, but we'll do our best. Let's get started. Jeff, what is Ralph?
Yeah, so there's it's taken a split meaning. Anthropic has published their implementation of my research that I published around about in July last year. And it is an implementation, but you're not going to get as good as an outcome unless you apply the general theory. So we'll probably get into some of the general theory here. The way the Anthropic implementation works, it just continually runs until it gets a compaction event. Whereas the general theory is what you do is you create a brand new context window every array, and on every loop you tell it to only do one thing, so you don't get compaction, you don't have any rot. So in the most simplest way, Ralph is really a very easy way to teach a concept. It's a pattern for an orchestrator. Now, you might be new to this term of an orchestrator. It's really simple. Imagine if you had 1,000 of these Ralph loops going. This is a way of allocating memory or tasks or goals to a high level thing so you can have 1,000 of these going. Like Steve Yegi's been talking about this for the last year, and he just released his with Gastown. I've got my own that I'm building live, which is Loom. Like I want 1,000 weavers going on. So in the most simplest way, it is a bash loop that deterministically allocates the memory, allows the LLM to pick like one thing to do in the task list, and you set it off to the races. And it's just a bash loop. But then again, you might be thinking, well, it's just a loop. Well, cursor is just a loop. Windsurf, all these things using every day is just a loop. If you think really carefully about it from the right angle, from GPT-3-ish days, we used to like, make me a Python application. And it would give you a Python application, and it was pretty terrible back then. So you'd copy and paste it, you put it into your IDE, you press run, you get compilation error, so you copy and paste it backwards, forwards. Tool calling and cursor is just the automatic copy and pasting. So you might be thinking, oh, it's just a bash loop, nothing amazing. Well, cursor is just essentially a loop of automatically copy and pasting. This is a loop for essentially, which will allow a scalable supervisor on top to run thousands of these things.
Okay. What would you say that was the first task that you ran Ralph on and you thought, holy shit, this actually worked? And alternatively, what did it fail at spectacularly before that worked?
Yeah, I need to do a huge amount of shout outs to Christoph, who is from the F# Inide team. Probably about 4 years ago, joined GitHub Next, and they published a research at GitHub Next about spec-driven development. Now, it was too early. It was like most recent, too early. That was in GPT-3 days, and it didn't pop off. But that research at GitHub Next proved that you could build an application in natural language. So I remembered that back in December. I had an Eng director come to me, tap me on the shoulder. It's like, you need to pick up the tools. Everyone in the Eng org needs to pick up the tools here. And I remembered the researcher spec kit by Christoph. He's in Poland. And I went with a specs or PRD based approach first. Now, and I just kept refining the approach from Boxing Day. I guess it's 2 years ago now. And I kept refining it by hand. I found myself like deterministically allocating things and then slowly changing my approach. I used to hire command, like telling it the multi-stage thing, what to do. And I saw that the models were pretty good at prioritizing things in implementation plans. So I started to learn to give away control, but keep high oversight. That was really weird. We got into programming because we're high control. We like controlling the computers. And I've learned in the last 2 years, I'm still controlling the computers. I'm programming computers, but what I'm doing is I'm programming the new machine, like the LLMs and the loop. I'm the orchestrator of the loops. Now, to get to your question exactly, it was around about February. It was around about February last year. And I was playing Factorio with my son, extensively playing Factorio with my son at this time, like maybe for 6 months. And in fact, we're doing our Factorio thing, a cursor on the side, and I'm just doing that. Dad, can you help me get a rocket in space? And he's just watching me. He's like, Dad, you seem to be doing a lot of things by hand, but it's the exact same way every time. Why don't you just put it in a loop? And I'm like, okay, he's 9. I'm like, I'm going to just put it in a loop. Holy crap. And the models weren't great back then. So I knew like where we're going. We're at like slope on slope improvements of these underlying models. It was only a matter of time before this would actually fundamentally change the unit economics of software development. There is a difference between software development and software engineering. Software development is essentially like a Jira ticket monkey. You could probably say that software development is over now because anyone can be a software developer. The cost of software development now is $10.42 an hour, which is lower than the minimum wage, and anyone can do it while they sleep. So if you identify as a software developer, it's some pretty tough times. But then like typing the code or writing the code, it's been fun, but it was never really the real job. The real job is really engineering, breaking down requirements and like engineering loops and like how could it fail, security and all that stuff. So it's going to be really important for software engineering. So the first thing I did back in February, I published something called the Z80. Z80 was essentially a research that was way too early, which detailed how you could clone a SaaS company, or how you can drive an LLM like a crypto mixer over intellectual property. The reason that we have Intel AMD CPUs today is because what someone did is AMD hired an engineer. They did some very dirty reverse engineering to the Intel chip. They got a golden parachute when they did that, but that person is now burned. They legally can no longer work at AMD ever again. And what that person did was sat down with a oscilloscope and like actually hardcore reverse engineered the CPU from Intel. And AMD can't use that work directly, any notes, whatever. But if that person writes a book or a specification, that's brand new IP, that's original, and that is legally clean. So that's what happened. That person gets a golden parachute out, and then AMD hires a bunch of people to implement from their brand new IP that describes a memoir of how the CPU works. So that's what I did. I took an application and I went through the steps proving if I could clean room with LLMs. And I took
You wrote a memoir.
Yeah. And a technique. I was like, hey, folks, wake up. Like things are about to change. And I took it like a sales tax calculator that I generated. And I took it through all the steps up to a spec, threw away everything so there wouldn't be any pollution. And then from specs, I made it run on the Sinclair Z80 from the 1980s. I'm like, oh crap, my toy example worked. And this was with a model that I used to describe, like Sonnet 3.5, I used to describe as a hyperactive squirrel armed with a kitchen knife. Like it's easily distracted. It's highly hyperactive, highly agentic, and it just wants to do things. And if you take your eye off it, you'll get stabbed. It's got a kitchen knife. But if you learned how to like tame the squirrel, you could probably get a salad.
Get something out of it.
You used to get something like that out of it. And the skill level to try and get something back then was like that. With Opus, it's like this, and it's just closing now. Like a year in, it is so much easier to do this technique. And now that my toy example had worked, I'm like, okay, could I clean room a company? So I downloaded HashiCorp Nomad source code, and I ran Ralph in reverse. A lot of people right now are missing the point that Ralph goes forward, meaning you can use it to build software. No, run Ralph in reverse to create a clean room specification. And when you do that, you can run Ralph in the reverse. And I was like, hey, study all this source code, completely don't care about the copyright, whatever. I'm just proving that I could probably, the toy example, could I clone a product feature set of like a product with they thought they were protected by their software license. And they thought that they were protected by not releasing some of the code, the enterprise core. So I ran Ralph in reverse, generate the specs. Cool, I got specs, but they're missing 20% because I didn't have the source code for the enterprise functionality. And you start, okay, I got a problem now. Like how? Like I'm not interested in 80% of an infrastructure orchestrator. No, it's simple. You run Ralph over their product guides, their marketing material, all their customer-facing things that describe the product feature set, and then that was enough to plug the gaps. And at that point, I was goddamn spooked. Like it was spooky back in Feb because I could see what's about to happen. That for founders, there isn't really no moat. And I was just on the loop, learning, really refining it. So I went out and did a lot of like talks. I started writing a lot.
Because you were concerned about the impact of this.
Correct. What does this mean now? Like, what does this mean now to be a software developer? What does it mean to be a software engineer? What does it mean when like software development is cheaper than like a burger flipper at Macca's? And I'm getting emails from juniors saying, hey, look, I've just completed uni. I feel absolutely screwed. So I want to get into that junior question just in a second, but so some folks, what they're doing essentially is like they're taking these screen captures of videos of products, and now they're saying, hey, pick up all of this, build a spec, and then build a product. But you actually use Ralph to go and read and understand from the source code, build a spec, and they'll grow from there just to prove the concept. Correct. That's what I did. So I use source code to prove that any company out there that's raised a large amount of venture capital who has adopted like a BSL license or some bespoke license, none of that matters anymore. That's not a safety net. It's gone.
Yeah, that's the quote of this podcast. Thank you. That's scary stuff. So I want to, again, go back to a point here that you mentioned. The cursor is a loop, and most of these tools are. And so the question to you, do you think that most of these modern AI agentic tools are just overcomplicated?
Yep. I used to, I professionally built these tools.
Mm-hmm.
Take it from me, you're probably in corporate right now and you're swapping between like, I'm going to Cursor today. Oh, I'm going to windsurf next week. Oh, we're going to do a evaluation of all these different things. You're just chasing your tail. The harness really does nothing. It's the model that does all the work. Because there is really no moat in the harness business when you're reselling tokens, all you can do is project a brand. I'm Gucci. I'm like I'm Louis Vuitton, etc. We're different. Now, some have a higher degree of taste. Like there are clothing and like bags and watches, etc. Where they're still just a watch, but they've got a high degree of taste in how they take their approach. So like they're all really just the same. It's the model that does it all. So you just do a little bit as a coding tool to do this. So yeah, we do complicate it, but however said that, whilst I've said that the Anthropic is not it, they've done a fantastic job of removing the need for me to teach a whole category of knowledge because they're making it very accessible. That I'm seeing videos on YouTube of like folks in the Bronx launching their like crypto project, what else have you, and they're like, yo, check out Ralph Luke, yo. I just woke up and built my entire thing when I was sleeping. That's only possible because of the work that Anthropic has done in Claude Code to make it super accessible.
One way that you described Ralph, just to continue doubling down on how kind of a mental model of Ralph for people, especially folks that haven't heard about it since today, or since the beginning of this podcast, you described it as deterministically bad in a non-deterministic world, which almost sounds like you're saying that failure is a feature of how Ralph and these loops operate. And so I'm hoping that you can explain to someone who's been trained their whole life that code should work the first time, or you want code to, like, failure is a bad thing. You know, this idea that failure is a feature.
Yeah, sure. I used to be, so there's a couple high level things. I fully believe that software engineering should be a licensed profession with perhaps if you work at a company that's contracted to build a bridge, if that bridge collapses, then that company should get liability, like the Iron Ring Canadian type topics. If before even AI, you Google, can I be a software developer? The top results say, yeah, anyone can be a software developer. It's so easy. But if you Google, can I be a veterinarian? It's like, no, you've got to go study. And by the way, veterinarian science is harder than being a doctor for humans. And this is like the stark difference of what we've been in. So that's always been really boggling for me. So that's the setup, right? I still believe in that. But the way I used to approach it was very much, I'm going to make a library and I'm going to put all this effort that it works. And I'm going to high control, figure out how it all works. And then I've got a Lego piece, and then I go Lego piece, and I build it mechanically piece by piece of known good components. And if something's wrong, I go look at what's wrong with that Lego piece. I update it, and like the tower doesn't topple or the bridge doesn't collapse. I now 2 years in see software development fundamentally different. Well, software, I still have the engineering principles. I now see the context window or the array kind of like clay on a pottery wheel, right? I turn the pottery wheel on. I sit down and say, hey, here is my specifications that are being built up through this technique of a conversation with them. And I use that as a pin for this, like, to describe that I am building a essentially autonomous weaving loom. And every time I do this process, it adds a little bit more context, which frames the future design. And when I want a new feature, I sit down, hey, I want to add attribute-based access management, ABAC. Study all my specifications so you can specialize, etc. And let's have a discussion about ABAC. Interview me. And then it would go, okay, I'll learn about the existing specifications and how the application worked. And this has been going from zero. Like there was no specifications. I just did this process all the way up. And the more that I do it, the better more context you're building, the more less it guesses about the domain that I'm in. I call this a model first company. Corporate doesn't have this. So I go, hey, attribute based. How should we do this? Study, etc. And I was like, it comes back with 5 points. And I go, yes, I want that. 2, no, I want it like this. This is where I put my engineering in. I'm engineering the clay. I'm engineering the clay on the pottery wheel. And then it goes it gives me a thing like, do you want A back or R back? And I'm like, well, I'm pretty sure I want attribute-based access control, but I don't know. You can actually then have a conversation backwards and forwards deeper onto the topic, and it will explore and expand the topic until you can make an informed engineering decision. And you go, yes, I want that. I want option C. And then you zoom back out of that, and you move on to the next one. And you just keep going that. And then at the end of this session, which is normally about 30 minutes, what you end up with is this pretty well-formed clay on the pottery wheel. And you just keep testing it. Does it understand what's meant to happen? You try it a couple of times and you're like, cool, it gets it. Write the specs, throw it to Ralph. And like I used to spend days thinking about the right architecture, the shape of my repositories and all this stuff, like architecting, XML, like UML type stuff. I can now, after that 30-minute session, get a rough cut. Like I do a loop by hand. Like I'm not even with Ralph allocating, but I use the principles to try to even test it. And if it doesn't seem right, I go back, I update the specs, I try it again. Prototypes are now free, they're now cheap, etc. And once I've got a high degree of understanding it's going to produce the right outcomes, then I just go back and I let it rip. And I get like something that is workable, not working, within an hour. You get weeks worth of work of potentially multiple co-workers in a couple of hours. And this is where it gets really interesting, is I still believe in engineering, and like if the bridge collapses, that's on you. But you know what? If it's wrong or if it misses something, I can throw it back on the pottery wheel. And I can do a crafted Ralph flip saying, hey, look, it looks like there's like you're duplicating the SQL all over the place. You're not using the repository pattern. So that's a refactoring Ralph loop. Oh, you forgot to do internationalization. Well, I'm throwing it back on the wheel. That's a separate Ralph loop. Refactorings are now cheap and easy. And the interesting thing is you can actually generalize that into essentially a Roomba that automatically vacuums your code base and repairs and does all these things. That way, you still have a forgetful Ralph that's doing its thing in building features. Doesn't mean when I talk about 1,000 Roombas or 1,000 like Ralph loops going, you can have an internationalization one. You can have a security one that just checks for common things that the agent forgets, etc. You can automate these things. This is a new class of engineering. Like we've got a new computer here, folks. What we've had over the last 40 years, we need to reimagine it for the new computer.
As Ralph goes in each loop, and it starts fresh, obviously we have the spec files as kind of the foundation or that clay, right? But what do you lose if you lose anything? What do you throw out? Like, is there institutional knowledge that dies in each loop?
Yep.
And that's okay.
That's okay, because my institutional knowledge is in the specifications file. So every loop, I allocate the specifications, which is the lookup table to other specifications. And that's enough to pin and reframe each loop that like, this is my domain knowledge. This is where you should look at certain modules. These are the patterns that you need to follow. And that's enough, because once you've done that, you think about from that point forward, you give it a task and goal, implement logging. Well, how useless is the implement logging if the logging is, you got a logging spec, and then 4 or 5 like features later, that's in the context window. It's basically that array has 2 or 3 different competing goals. And if you think about context windows as an array, sliding window, etc., And we know that the more you use an array, the context window, the dumber it gets. And then you get stuff like compaction. What happens if compaction removes the pin, the specifications? And then it starts making stuff up. So it's really simple. Avoid compaction at all costs. Deterministically allocate the description of your application so it could use it as a lookup source, and then pick one.
Okay. So now I want to move on to more spicy subjects, and those are essentially how we look at the industry. So you've been very vocal about essentially not hiring any junior or mid-level, even software engineers, which is terrifying, right? As just a statement. So you're saying essentially that entry-level path into software engineering is closing?
Yeah, it closed for a while. I was at Canberra. The doors shut at Canberra about a year ago for juniors until we figured out how we're going to interview again. And then we opened it back up again once we figured out how we're going to interview again. Like how do we identify someone that's been curious? It is very important to raise the next generation of software engineers who think like software engineers. It is still really an unsolved thing how we raise that next generation. You need to completely replenish that pool, and I believe firmly in apprenticeship. Having said that, there is a hard line coming, folks. There's a hard line coming. If you're only just picking up the tools today, and after Opus, because you finally discovered that it's great, understand that a lot of my writing and research, it got syndicated with the Prime Gen like 6-7 months ago to an article that was just, hey folks, hey juniors, pay attention. You're screwed unless you pay attention here and invest in yourselves. And that kind of popped off, and I started writing like how to build a coding age and teaching the new comp sci fundamentals of like the inferencing loop, etc. I think that's like 4.5 or 5Ks on GitHub, which is great, right? So we now have essentially at least 6 or 7 months, like half a cohort of juniors who will work at a quarter of the wage that a senior software engineer is on because they're young, they're juniors. And it's not just it's not that they're working with these particular tools. They found discoveries. They found that like you can drive loops that automatically copy and paste. Like for example, an example of a loop would be a workflow loop. I know that I can drive the model to using tmux, and then once you command it to use tmux, it will automatically scrape the panes and copy and paste that into loopback. So I no longer need to be at the computer as much because I've automated that loopback. Another classic loopback is like use the GitHub CLI to automatically resolve the CI failures for this pull request. And it just does it. And it's that knowing of the techniques. Once you make that discovery, that's your edge, that's your advantage. So we've got juniors now, 6 months playing and making these discoveries of loopbacks, etc. If you're just starting now, you think you've got it. No, there is a lot of knowledge that you have to learn and techniques, and this is becoming AI native software engineering.
Yeah.
So,
and if I may offer some resistance to that, one of the things that I see though is that where a junior could learn some of these ideas and it's playing how to code already with tools like Cursor and now playing with Ralph and so forth, a senior, from what we've seen at least, or from what I've seen, can have so much more resistance to offloading ownership and leaving kind of the old engineering practices behind. I'm even seeing a paper today that senior engineers like to maintain ownership of code and the practice and the agent, right? Whereas what we're discussing now with Ralph is screw ownership. Here's the spec, go build it, do it in parallel, and whatever you do, just get there, right? And so my hope is that as we get farther into the future, I can agree with you, if anyone is learning how to code and does not take this into consideration, yeah, it's going to have a hard time. But if they are, they don't learn the old vices, so to speak. Does that make sense?
Yep. Let's play with this. Okay. So these tools in the hands of a junior is dangerous. It's kind of like a woodworking shop. Like they don't have the experience to know how a table saw can take your finger off, and they don't have the stories, etc. So you need to supervise them. You need to mentor them. Like you're the workshop supervisor in your high school, and you're supervising your class. You can't use a lathe until you don't have a tie, no high hair. Like it doesn't care about taking a finger off or strangling you, right? And a junior won't really have some of these domain knowledge of like how to be an engineer. I think that's our opportunity. But if you've got a junior who's learning these concepts, they're so much more mentorable, and a surefire bet than someone who doesn't have that. So that's the difference. Now, for the senior side of things, well, what happens when a company's commit graph looks like that? Not that commits is the right measurement here, but like commit drifts like that for the high performers. And what happens when the high performers are basically the leadership team, and they're discovering Ralph, and they can run their organization, just the three of them, and the rest of the eng org, commit velocity and product velocity is like that. The eng team's like that, that's like that. My deepest fear is people think they've got time. No, the unit economics of software development is forever changed. You need less humans. So the way I look at it is AI is an amplifier of operator skill. It amplifies the knowledge that you have. If you're really good at security, really good, you got that brain and thinking about like, when I get hacked, what is the blast radius, and like really thinking about these things and then thinking about gadgets and widgets, that is amazing. If they get curious and they get really good at AI, they turn into an absolute weapon with it. And it's the same with in any discipline. Accounting, like legal, software engineering, etc. This is the new thing, is like actually being curious, playing with it, and then automating your job function. Now, if an engineer is like, oh no, whatever, like I see online, and I can't believe I read this last night. There are really respected software engineers that I respect in their craft taking a hardline stand. No, I will never use AI because that is fascism. That's installing fascism in your code base. I can't believe that stuff from 2019. Someone is going to take such a hardline stance and not going to make it. In that sense that like their commit velocities like that, a product velocity like that, founders are learning. They're going, why would we pay the payroll of that person? We're Ralphing now, and that's my one of my concerns. Like you can send down ladders, etc. But there's a hard line. There's a hard line coming.
Yeah.
Just because you don't feel it in your current company doesn't mean it's coming.
It's not real. I understand. I want to explore that idea of skill of AI. So that distinguish that idea that separates between someone that is skilled using AI native flows or thinking with AI vis-a-vis someone that is unskilled. What do you think makes someone skilled in AI assisted development?
It's the discoveries. It's the discovery. Like
the exploration.
You can go to my YouTube channel. You can learn how to Ralph. You can learn how to do specs and PID. You can go back to the GitHub Next research about specs and PID, which kicked this entire thing off. I haven't actually seen them properly cited for this research, to be honest. But it's the knowing of the tricks. If you pick up the guitar and you play it like this in the particular way, that's a C note. Like some of these things don't actually have language or terms to them. We're inventing the terms for the new computer every day. And we're trying to get consensus of this. So it makes it really hard to actually teach these things. But the main thing I can talk about is closing the loop and looking for opportunities to automatically copy and paste in the context window. I feels like I'm picking up my first computer again. This is a brand new computer. And with this new computer, you can start thinking, someone who's like far along the journey sees this is some of the most exciting times, and we can reimagine what the new computer is. And because how the last 40 years until we get from here to there to where we are now, it was everything, all the design decisions were for humans. Like, why do we have a TTY? Well, so the human operator on the mainframe could type. Why do we have environment variables? Well, the human need to configure an environment variable. Like, and then you start going, wow, Unix is based on 40 years of decisions for humans. We got robots now. What's the bare minimum robot needs? And then you start thinking, well, what about programming languages? We never used to do breaking changes, and we used to be very slow in our pace of language development because we would break humans and their mental model, etc. Well, what happens if programming languages start Ralphing by default and their velocity is like that? No committees, none of this garbage. They just go, here it is. You want high kind of types and Rust? There it is. Like, a breaking change is now cheap and free, because free compared to what it used to be, because you just run a Ralph loop to auto migrate the code base. You can just publish an auto migration script. And so the back compat and all that's really changed. All those concerns are really changed. So the skill level is really the discoveries of loopbacks, and there's a new mindset. Meanwhile, people would be like, if they're just using Cursor to like ship their things, etc., they might be not picking up why some of the biggest names in comp sci have come out of retirement. Like, why are they excited? Learn why they're excited is what I'm talking about. We've got a new computer. We can dream what the new computer is. We're building the new computer every day.
And so in that example of guitar learning, when you're a teenager, you have what feels like infinite time for you to, play and explore. But what would you say to that mid-career engineer with a mortgage and kids? Where do they find time for that deliberate practice?
You just make it happen. I've got kids, right? I like to describe this as, we've got this magic space dust that allows you to teleport to the future and steal and rob your retirement plan from yourself. What are all the ideas you're going to do when you're retired? Do it now. You can do it now. Like the idea of making a programming language or a Game Boy emulator or even a damn operating system. Like, I started doing Ralphing an operating system, and I just stopped. Like, okay, I've done enough novelty stuff. I've done a programming language. I definitely can do an operating system. Actually, one of the mono engineers behind Xamarin, they built an operating system over Christmas using these techniques. So you make the time and understand it can build while you're away from the computer. So the amount of time I've got to spend I've got to spend 60 hours to learn this new thing, a new program, I don't have time. That doesn't make sense anymore. You can just like pick it up for 30 minutes and try different things. You can discover new techniques. You just pick it up for 30 minutes, put it down. Pick it up, put it down. Don't watch some Netflix. Just like pick up the guitar. You'll know when you truly get it why all the comp sci people are out of retirement, because if you have trouble sleeping because you're so excited about what you can now build, you get it. You really truly get it, because you can teleport to the future, build all the things you've always wanted to do but you never had time to. You can do it now, right now. You have been able to do it for the last year. So you make the time. Now, the interesting question, if we split that, is you're a mid-level software engineer and you're like, there's no way what Jeff is talking about is real, because I don't see it around me. Everyone around me doesn't see it, doesn't get it. No one else gets it. Well, I hate to put it forward to you, but like there'll be a time when you'll be you'll be teleporting to the future and implementing all your things, and you will get it so hard you won't be able to tolerate people who don't get it. So you'll seek to be around other like-minded people, and you'll understand the rising tide here, and the rift that's forming, and you'll go seek to join a model first company of those who see it. So if your company is outright banned AI, well, the only time you can get good at AI is at home. That sucks. The perfect place is that you play with it at home, you make a discovery and you play it at work. At work, you play discovery, you play it at home. You've got this loop going on, etc. For any other big corporate type thing, it could be like 3-4 years of a agile transformation program. They roll in Accenture coaches that teaches everyone this is how you do AI engineering, etc. It's already happening, but like, seriously, what's the quality of those agile coaches like AI? Like,
no, they're outdated by definition. By the time they create programs, they wait a week and it's already outdated.
It's gone. Like there's probably 5 to 6 people in the world that I rate as brilliant. Like the pool is really small. We're all sitting in WhatsApp groups, like riffing each other on, sharing ideas. Like, you go do that. Like, I've got folks who are just that. Like, let's get rid of user space. What does agent space look like in Unix? They're exploring that. These are low-level engineers thinking, how much of the operating system can we cut?
Oof.
And they want to try. Okay. Yeah, they're heading that way. I'm looking at, can I have an automated software development, automated weaving loom? What are the software engineering practices that no longer make sense? Why do we have CI? Why do we do code review? Like, questioning everything. And they're doing the opposite for low-level computer internals.
Wow.
So it's really strange. My biggest concern is in these corporate transformation programs is it's going to be 3 or 4 years where they do the transformation. You might feel that you're safe, right? But what happens if that corporate you're in is 5,000 employees, they've raised a large amount of capital, and the unit economics changed on that company? Like, software development is now cheap. They've overhired software engineers or over people before AI. And you're working at the company, you're doing the transformation, you might think it's going really well. What happens when there's a couple of people that just in their 20s, they go to Bali and they run the Z80 and Ralph, and instead of charging $100,000 a month for the enterprise SaaS
they go after your product, They
go after your product and they charge $1,000 a month. And they can turn things around faster than the bigger org. We all know smaller teams ship faster because there's less hierarchy. So I'm very concerned it's going to be kind of like a Titanic moment. Sorry, the boat is full. Get the next boat.
Yeah. So we're on time for questions, but I want to just get one final one in from my side, because the conversation has been so entertaining and valuable. What would have to happen for you to conclude that AI assist development is overhyped? What will be the thing that you'd say, yeah, I was wrong about the timeline, or I was wrong about the magnitude of change, or what would have to be true in order for you to make that statement?
It's a fantastic question. I originally was the person that was hardlining that AI is hype, and everyone that turned up talking that AI was pretty amazing, I just wrote them off as a shill. That used to be me. What was really happening is that person was genuinely concerned that, yeah, it's getting good. And they're trying to communicate to me, yeah, it's getting good. It took a conversation with a founder talking about like the unit dynamics of businesses changing and the bar, and you need to get back on the tools for me to go, oh shit, right? And then I could see that it's a slope on slope improvement of the capability, and the skill level needed to do things. I thought that would be like a safety net. Like Opus, every time the model gets better, the skill level to drive these things is just getting easier and easier. So you got these random people on YouTube going, yo, check out Ralph Loop. And Anthropic is taking these concepts and made them super accessible. So I guess I was wrong about the time frame. I thought that like when I showed Ralph Loop about 6 months ago and published it, people would get it. Maybe I could have done better in teaching it, etc. The people in San Fran I showed it to, they got it immediately at the meetup because they're used to thinking in exponentials and they're deep in the San Fran culture. I presented that and it was, geez, we spent like an hour after the presentation and we were just going, shit, what does it mean now? What does it mean to be a founder, etc.? That was 6 months ago. And then they got showed in Y Combinator, demoed internally in Y Combinator, and there's like half a batch now or have been Ralphing for 6 months. So like this entire notion of like a couple people in Bali going after the corporates that don't transform fast enough, it's real, folks. It's real.
They're going to get Ralphed.
They're going to get Ralphed. Their actual business model is going to get Ralphed by Ralphed. So I guess I was wrong. I would have expected it to happen kind of sooner. I still potentially see maybe AI as a bubble, right? A lot of these labs are lighting money on fire. I do not deny that. But at the same time, I cannot, it'll be a false equivalence to say that for the last year, I've been writing software while I sleep. Like, yeah, like that's pretty crazy proof. And then when you got the social proof of like all these YouTube videos of non-software developers that would normally go to Lovable, just installing Claude Code and implementing their wildest dreams. So maybe how can you still say it's a bubble? There's actually economic utility coming now, and founders are starting to go, well, let's rethink about our business plan now. Maybe one of these frontier labs explodes because they light too much money on fire. That's none of our concerns. We have open source models that can run on local hardware. We'll probably have Opus level intelligence that can run on local hardware if you've got the hardware at home within the next 6 months, right? If they go boom, so what? So what? We're not going back. I'm not crafting code by hand. We've got a CNC machine. There's no way I'm going back. Like, we've gone from essentially carrying cargo by hand to we've now have a locomotive that just goes. And it's our job now is to be locomotive engineers to keep the train on the tracks and to build the tracks, etc. And to be engineers, because there's no going back once you've got a locomotive and that automates things for you. So I guess I could be wrong on many things. I think what I'd like to really pass on is, as certain as I am on these topics, I don't bloody know. And I think anyone who says that they know is selling you horseshit. Like, I've sat for the last year figuring out where and how product will go in all these scenarios after the discovery, and game theory up where it goes. So I've got a kind of idea what the shape of like the tree and the structure of how it could go. But everyone says all these absolutes. Yeah, there is no knowing. Please understand there's a brand new computer. And if you aren't excited as I am about a new computer and you're like, wow, what is this? And like doing invention discovery, it's time to start picking up the guitar and playing.
And that's a great segue to opening up the questions to our audience. We already have a number of them. Please do post. We'll have 9 minutes, but we'll try to get as many as we can. So Andrew asks, does the current Ralph loop within Claude Code plugins ecosystem actually start with the free context window after each task? My advisor said there was an additional script to get it to perform as such.
Yeah, so have a look at the implementation. Have a look at my video on YouTube, where I teach how I build my specifications and PRDs. I see a lot of people saying, "Oh, Ralph Loop will never work because I got to spend all this time writing specifications." I code gen all my specifications. So for the internals of that, watch my video, run an agent over that implementation, and then compare those notes together. This is one of the things you can actually. This is one of the techniques. You can ask these questions, and it's a very good question. but this is now what I would normally use Ralph for. Like I get an academic paper and instead of spending 3 or 4 days to read and find that information, I run a Ralph loop to replicate the research. I do a prompt, split this 100-page PDF in CompSci or in ML and convert that to Markdown and give me a working prototype, because I think and feel in code. I need to see it in code. Now I can do that. So the main thing is that you could do the Claude Code plugin, etc., and all the differences. We can focus on that. That's missing the bigger picture. This is an orchestrator pattern that can orchestrate thousands of Claude codes. That's where we're going. This is where Yegi has been doing, welcome to Gastown. Welcome to Gastown. Because the orchestrator can make intelligent decisions. You could maybe call the orchestrator Lisa or Milhouse. And it tells Ralph what to do, and it can be hyper-personalized. You need to, anytime internationalization happens, you need a Ralph loop to make sure all the things internationalized. If you're still thinking like I can just use Claude Code one-on-one, you're missing the bigger picture here. We have an automation primitive. You need to be thinking about how I can automate your job function. So you can do the plugin, and if you do the plugin, you're going to be doing so much more productivity and output than everyone else. Just understand there are people like me who are thinking about robots and robots and robots and loops and loops and loops. And there are other people since the publication, they are building the Lisa, building the Milhouse, and they're thinking about this as essentially a Roomba, and they want to be programming the Roombas to automate their things. So it is important to have a brand new context window, and people are going to be playing either way. I'm very friendly with the Anthropic team. I'm completely neutral to them. Like they don't pay me any money, what else have you. And I'm very thankful for what they've done in making this more accessible. But if you're just using the Anthropic plugin, you're a consumer. You're a software engineer, aren't you? If you're just going to consume the thing and not understand how it works, you're just going to be consumer. Yeah, sure, you'll make the cut. But like the rewards go to the people who are the engineers who automate their job function with AI.
Mm-hmm. Mm-hmm.
And to do that, you need to be thinking about orchestration.
A user in YouTube asks, how do you get Ralph to rank order potential frameworks/platforms you're evaluating while building?
Well, this is going to be weird. So yes, I own a farm. Goat farmer. Yes, I own a farm. I used to be one of the maintainers of React extensions. I used to be very prolific in open source, and I did an entire bend for multiple years about getting open source financing and pleading companies to like donate to maintainers, etc. Maybe we can change the world if we support the people who support the corporates. And like the settlement of my land, like the property conveyancing fees, were all funded by Open Collective. That's the setup to this. I no longer use open source anymore. None. Because think about the problems of open source. If there's a bug, you got to open a pull request, you got to go chase a human. You got to inject a human into the loop. Anytime you tool call a human, that's not AGI. That's not Ralph. So it is much easier now to code generate everything. I've got a blog post about this. Is what even is the point of open source now, that you can code generate it. Now, you wouldn't necessarily generate cryptography libraries like PKI. I have, but I wouldn't put it in production because I couldn't stand by my engineering bar. But you know what? There's got to be a PKI engineer who Ralphs and understands the domain and go, that was amazing and that is safe. Right. So there's got to be these lines, and you've got to reevaluate the lines of what you will generate and what generate. So if you're thinking about frameworks, you are missing the entire point, unfortunately. And I say that with absolute care. You actually need to rethink about things now, like how do I not have humans in the loop? Frameworks no longer matter. We made frameworks to make it easier to hire for humans. Like React Cool. We want 2 years React experience. Is that still true? Is that still true? And it gets really weird. So you can actually just make a framework like that, or maybe you don't even need frameworks. I definitely, there are boundaries and lines. Like, I'm not saying that we should go like ignore Ruby on Rails. It's in the training corpus and it does it really well. So still use Ruby on Rails, right? I'm not saying that we should get rid of React. Use, maybe you just stay with React or Next.js because it's in the training data. It does it really well and you're going to get better outcomes. However, what about the libraries in React or Ruby on Rails and all that? Instead of installing those gems or those NPM dependencies, just code generate them. So you have like a stable base and heart of the framework, and then everything else is code generated. Or you approach this from first principles and go, I just got to do the entire thing. I like rebuilding engines. It's now possible to rebuild an engine just from an idea. So frameworks, I guess there's something I've been thinking about programming languages. There are, if you're like, there is like a tier list of programming languages. I like to see, unfortunately, F tier is Java and .NET to me.
Okay.
And for reference, there's 600 people on social media that the official Microsoft .NET account follows. I'm one of them. I did a lot in .NET. I'm not saying this because I hate it. Because the way that these coding agents works, the search tool uses the bash tool to execute ripgrep or grep. And that discovers a function signature or what else have you. Things like node modules. We used to joke about like it used to be the way to the black hole. Well, because it's source-based, not a DLL, NuGet and .NET is DLL, ripgrep can run really well natively. But if you want to get that type of stuff going in .NET, you have to do these crazy context engineering type things and all these other things that other programming languages get by default. Mm-hmm. So what makes something F tier? What makes something S tier? Anything that's source-based with strong type systems that reject anything that's source-based so that with strong type systems, so it can run ripgrep through it, and the type systems reject invalid generations. So TypeScript goes very hard.
Can you name one S tier? What will be one that you name?
Rust is amazing. Rust is amazing. Python is so-so, but when you drive it with Pydantic, with that knowledge, you should use Pydantic. Mm-hmm. It's definitely S tier. TypeScript is really good as well. S tier, if you do TypeScript with Effect.js, wow. Okay. Because that's taking the idea of effect programming and making it very accessible, which makes things very testable, incredibly testable. But there are trade-offs. Like Rust, the compilation speed on Rust is very, very, very slow. Very, very, very slow.
Yeah, so those are all trade-offs,
The trade-off, if the compilation takes forever, what happens if it does an invalid generation or hallucination and the compilation takes 30 minutes? Well, you compare that against, say, like TypeScript. In that time, how many generations has it done? Because the generative function will be bad. So if you do choose Rust or C++ or what else have you, you got to be an engineer and make that back pressure fast.
Yeah. We got to do a bullet round because we're already on time. So we got to do very quick answers to some of these questions so we can address them. Very quick one. How will you implement Ralph on an existing code base? From Stallion.
It's really hard to give broad level guidance because Ralph is essentially unleashing an autonomous junior engineer with a kitchen knife. Like it actually can be quite dangerous. In the existing code base, hopefully you got tests. Okay. Most enterprise stuff I've come across doesn't have tests. So maybe don't even think about it. Remember the Joel Spotsky thing, things you should never do, which is rewrite Netscape? I think that's now falsified. It might be easier to rebuild the application from scratch with specs, with the techniques, than it is to adapt the existing code base. this is what, like, try it. Just try it. So the first thing you do is you need to be creating the back pressure, which is the doing the tests and making the maintainability. The next thing is you should be thinking about sandboxing. Can your application run in a sandbox, a Docker container, and all the rest? If you can't do that, then don't even bother. Rewrite it. Then you start building the specification library. You can run Ralph in reverse on your existing code base to generate the specs from like the Z80. And then you critique that, and maybe you can bootstrap your project. Just know that you're going to be going through a lot of pain to try to fit the old world in with the new world. And you're going to be dealing with people problems like, I want Hungarian, I want snake case, I want Pascal case. All that's just noise now, folks. Like, what they go, oh, AI doesn't create maintainable code. For who? Why are humans the benchmark? If you can rip another agent through the code base and it can like add the ABAC things that missed and identify all that stuff, why are humans the standard for maintainability? So I would try to generate the specs going in reverse, but it's hard to create. It's hard to create broad guidance on this thing.
Yeah,
it's impossible.
Right. Do you agree with that the concept of shareware has returned?
I don't know. I think we're in a GeoCities moment. Like we're back to Commodore 64s. We're going to have everyone like
GeoCities was such a cool moment in the internet.
Yeah, right. I think we're at the GeoCities moment. Like everyone is going to teleport to the future and invent all they wanted to do, and they're just going to give it away. Or maybe they keep it to themselves. I think we're going to see a whole bunch of like the same way in Commodore 64. It's like, hey, mate, can you copy me that floppy? Like someone does something, even if they don't share the source code or they do some documentation, whatever, just that idea that it is possible, they're going to go open like Super Whisper or Whisperflow and go, hey, that person over here, a really good idea. They describe the features, etc. And they got their own copy. So the topic of moats is kind of going to disappear. I think it's going to be a beautiful time for a software engineer. But as software development, that profession is now closed. Yeah. Because it's been replaced with a Ralph loop.
And I guess one final question just to end up from YouTube. Would it be fair to say that we are seeing in software engineering now will be true for most fields requiring creativity as well as a defined process such as finance, law, or manufacturing?
I don't know. Let's play with it. I don't know. I think so. The reason why this is happening so much in our profession is we can be mechanically verified. So if you think about, I've talked about the wheel, or the notion of a wheel. So you have a generative function, and then you got the bottom half of the wheel, which is the back pressure. The back pressure, if it generates something wrong, the test pushes back on the generative function to try again before the wheel's allowed to turn around. Any discipline where you can do that is going to be automated. That's absolutely certain. When you can mechanically verify, it's going to be automated. Now, I guess, what is the failure rate for humans if it can't be automated? Let's say you take a lawyer. What happens if a paralegal makes mistakes? What if the LLM definitely will make mistakes. What if the error rate on an LLM is less than the rate of a human, and they're already used to the idea of failure? And that's why they have 3 or 4 different people read a contract before it goes out. So like this is how I've never worked in the legal profession, but this would be the approach I would take in a legal profession. What I'll do is I'll build a whole bunch of like common red lines, clauses in a contract, like underlines, things that you want to keep an eye out for, and I'll turn them into test cases. And I'll keep those contracts around, and I make sure when I change a model, this is evals, that like it detects these type of test cases. Doesn't have to be 100%, it needs to be 90, 80%. You get used to the failure, because like even in biology, humans, it's never been like 100%. It's been random chaos. And then when your new contract comes in, you have a look, did it detect it? Oh, wow, we've got to speed up. And you can never outsource accountability to a machine. That's always on the human. But what happens when a lawyer / engineer, they exist out there, they're both lawyers and engineers, take these types of approaches, and they start instead of having to look for this, they're actually building up a linting library.
For law.
They're building up a static analyzer library for law. This is the approach I would take. I would not be surprised if they take this approach as well. And so
Cool.
their burden is a lot
cool.
less. Yeah.
Cool. Folks, we're on time. This has been a fascinating conversation, truly worthy of a start of the year in season 2 of AI Giants. Jeff, I'm so thankful for you accepting the invitation. Thank you for your candid, honest, very truthful type of dialogue that we had here today, and for answering some of these tough questions and answering also questions from the audience. Thanks for being here.
No problem. Thanks for having me on. As confident as I might be, I don't know. But one thing's for sure, I'm not going to be stuck like a deer in the headlights while this goes on, or wait for the next model to get good at this. I hope people who watch this go out there. I've got a workshop that teaches you how to build an agent. This is now the baseline fluency. If we ever cross paths and I'm interviewing, I want you to be able to explain that on a whiteboard. I'm making it very clear what the new lines are, and I hope people invest in themselves, because I want to increase the pool and the moat of the people who can actually use the new computer.
Wonderful. Great. Well, folks, today we looked behind the scenes at the origin story of Ralph with the great Geoffrey Huntley. Fascinating conversation. I hope you had as much fun as I had. As always, we at Codacy, we are an end-to-end solution for building products safely. Next week, we are joined by the CTO of Vercel, so please don't miss out. And with that, have a wonderful rest of your week, and thank you for being here and for all your questions. See you guys.
See ya.